This is a recording of my screen as the code for traffic.py, my code traffic.py is being executed. I've taken the liberty of executing the command beforehand because it takes some time for my machine to load TensorFlow, especially when it does not have a GPU. So here's my command to execute the code. And as my model is being trained for the very first time, let me go ahead and explain my code. But first, let me reduce the size of the terminal. Now that it's out of the way. Okay, so the global variables are unchanged, and so is the main function. The load data method, let me explain that. The method takes in data directory as its argument, which essentially is a string that represents the main directory where the images are stored. But the data directory contains subdirectories, each named with a certain number ranging from 0 to 42, and each number represents the category the image inside should be classified into. So I've got myself the full directory name by concatenating the current working directory, the data directory, and the string of the number, that is from 0 to 42. Inside each of these category directories are images which are read through OpenCV. The images are represented as a NumPy matrix wherein each element is a pixel value. Once they've been read, I've resized it according to the specifications given, that is image width and image height. I just made a tuple out of that for myself right here. Once the images have been resized, they were scaled so that they reduce computations in the future. And finally, I've assigned each image a certain label, which essentially is the number or the category it belongs to. So the method returns images and labels. They're both lists. Okay, moving on to the model. Now the assignment requires us to deploy or use a convolutional neural network. My model contains two layers of convolutional layer. I've used 32 kernels, and each kernel matrix is of size 5 by 5. The particular choice of these parameters were done through observations while tuning the model with different parameters. I've tried tuning the model with 32 kernels, 64 kernels, and even 16 kernels with various sizes, a size of 3 by 3, a size of 5 by 5, and similarly I've tried varying the pool size. Yes, the choice for this particular model is a 2 by 2 pool size, but I've also tried with 3 by 3, but I got marginally better results with this particular combination of parameters. Okay, so let me explain the model. First, convolutional layer, followed by a pooling layer of the given pool size. These layers have been followed by a second set of convolutional and pooling layer, and the output of these layers have been flattened only to be fed into the neural network. And finally, the outputs have been taken from the nodes of output layer. Each node outputs certain probability, and the activation is softmax for the output layer. And finally, I've compiled the model with using loss function, that is binary cross entropy, and the metric that has been used to evaluate the models is accuracy. So as you can see here, the accuracy gradually increases with every epoch, and the loss decreases with the 2. So now let's wait for the model to be trained completely. You can see that the accuracy ranges, the fine accuracy ranges in about 95 to 96%. Hopefully it increases as the training comes to an end. So at the final epoch, the accuracy was of 96.43% with a loss of 0.0048, which is, I think, acceptable. And the overall accuracy here is of 98.35% and a loss of 0.0028.